you a song, tell you that I'm leaving but I won't be long. If it was up to me.
What is going on, guys? It is your boy P here talking about the citric acid cycle or the Krebs cycle or the TCA cycle, whatever you want to call it. I haven't been here in a long time, so I hope you guys enjoy this video. So if you haven't already, go check out the glycolysis video. There will be a link to that video in the description and on the screen right now. So we talked about glycolysis, and to get to the citric acid cycle, we need a certain link. So we have a process called pyruvate decarboxylation, and it's summarized here. So we have pyruvate combined with the enzyme CoA to form acetyl-CoA, and in doing so, we release carbon dioxide and reduce NAD to NADH. And this is all catalyzed by an enzyme complex called pyruvate dehydrogenase. So once we get our acetyl-CoA, we are ready to begin the process of the citric acid cycle. Now let's take a look. So we have our beginning acetyl-CoA, and the 2-carbon acetyl group is transferred from it and combines with oxaloacetate to form citrate. And here citrate is then rearranged to form isocitrate, its isomer conveniently named. Isocitrate is then oxidized to alpha-ketoglutarate, and in doing so, since there's a large drop off in free energy, NAD plus is reduced into NADH. And so we also release a carbon dioxide because we are removing a carbon dioxide from isocitrate to get to alpha-ketoglutarate. And then we oxidize alpha-ketoglutarate to succinyl-CoA. And here again we get a drop off in free energy, and so we release a carbon dioxide because we're removing a carbon dioxide anyways from alpha-ketoglutarate, and we reduce NAD plus into NADH where we store its energy. This step right here is almost identical to the oxidation of pyruvate, which we just discussed earlier. From there, succinyl-CoA releases coenzyme A, and it becomes succinate. And succinate, the energy it takes to release coenzyme A converts GDP to GTP, and in turn converts ADP to ATP. So this is facilitated by an enzyme called NDK. So in converting GDP to GTP, we also convert ADP to ATP. Succinate is then oxidized to fumarate, and the energy here is stored in FADH2, which is the reduced form of FAD. Fumarate and water then react, and this forms malate. And malate is then oxidized to oxaloacetate, and again, NAD is reduced to NADH, and now oxaloacetate can now react with acetyl-CoA to re-enter the cycle. And so what we need to keep in mind is that we created 2 pyruvate molecules. So that means we have 2 acetyl-CoA molecules. And in doing so, we have the cycle turn twice, or it goes around twice. What we got out of it was 3 NADH molecules, 1 FADH2 molecule, 1 ATP, and the release of carbon dioxide. And this carbon dioxide is the carbon dioxide that you exhale in the action of breathing. Now we have to keep in mind, we're looking at 2 molecules of acetyl-CoA, so we can double what we would get out of a citric acid cycle in 1 turn to 2 turns, so that would be 6 NADH molecules, 1 FADH2, 2 ATPs, and again the release of carbon dioxide. NADH and FADH are very energy-rich molecules, and they're used to generate a lot more ATP later on. We'll check that out in another video, but for now, guys, the more you know, the better you are.